Welcome back to my class. In this series of lectures, we have already learned about various types of passive elements and also energy sources that we use in electrical network or circuit. Now, since this series is about electrical network, in future course or in practical life also, we will come across various types of networks. So, before we start simplifying those networks, we should have a good knowledge of their types or classes. So let's start the class. The first classification is linear and nonlinear network. Now a linear network are those networks where the parameters are constant and they don't change with time and they do not change with voltage or current. In case of linear network, it obeys Ohm's law and it also satisfies the law of superposition, means the law of additivity and homogeneity. Suppose we have an electrical network where as input if we apply a signal xt and if we get an output signal yt, then now suppose if we multiply this input signal by a constant multiplier a, then the new input will be axt. So if now we send that new input a multiplied by xt, then from that electrical network if we get ayt output, then we can say that this network is obeying the homogeneity property. So the input is multiplied by a constant multiplier and the output is also changing by the same proportion. Now suppose if we take two input signals for the same network, say x1 and x2, x1t and x2t, and if we multiply both the signals by constant multipliers and if we take their values, different values, and if we add them, now through that electrical network if we send this combined input, then from that network as output if we get this type of signal a1 y1t plus a2 y2t, then we would say that this network is a linear network where y1t is the output corresponds to x1t input and y2t is the output of that network when we send x2t as input. So when we are multiplying both the inputs separately by different multipliers and then we are adding them and we are forming this type of input, then the output will also change according to the change that we have done in case of input. So this is the law of superposition where we are satisfying both the additivity plus homogeneity, both the properties. Now as example we can take resistors, capacitors and inductors as linear elements and a circuit where we have all these passive elements that can be considered as a linear circuit. So in this type of linear circuit, the parameters do not change with voltage or current. This is a simple linear circuit where we have a resistor, capacitor and we have a voltage source. Now for a simple resistive circuit, if we draw the VI characteristics, then it will look like it will be a straight line. In case of linear network, the VI characteristics is straight line. Now in case of nonlinear network, the parameters, they are not constant with time, rather they change with voltage or current value. And also these nonlinear elements, they do not obey Ohm's law and also they do not satisfy the law of superposition. That means they do not satisfy the additivity and homogeneity properties. And in a circuit, if it has at least one nonlinear element, then the circuit or network will be a nonlinear network. In case of a simple circuit where we have only one diode and that is energized by a voltage source that we can see here in this diagram. Now in case of diode, when it is forward biased, then the current flows through that diode or in that circuit. But when that, if we change the polarity of the voltage source and when the diode will be reverse biased, then no current will be flowing through that diode. So if we draw the VI characteristics of this circuit where we have only a diode, then it will be a curved line. So this type of characteristics we will be getting. So in case of nonlinear network, the VI characteristics is not straight line, rather it is a curved line. Now, next type of classification is unilateral and bilateral network. In case of unilateral element, what happens is these elements, their property changes with the change in polarity of the supply voltage or maybe with the direction of current that flows through that element. So it allows the current flow through it only in one direction. Now again, if we take the example of diode, and in this simple circuit where we have only diode and one voltage source, as we have seen previously that through diode, when it is forward biased, then only current flows through that circuit or through that diode or element. So it will be an unilateral element. So if we draw the VI characteristics, then the variation of current with respect to voltage will be like this. But if we change the polarity of that voltage source, then a very small and very negligible, or we can say almost no current will be flowing through that diode. So it depends on the polarity of the voltage source in that network. And a circuit or network that has at least one unilateral element, then that network is called unilateral network. So rectifier circuit is a good example of unilateral network. Now in case of bilateral network, the bilateral, it is made of bilateral elements. So if the network, all the elements are having that nature, then it will be called as bilateral network. Now a bilateral element is that element where the property does not change with the change in polarity of the supply voltage or direction in current. So it allows the current to flow through it in both the directions. So as for example, we can take this circuit where we have a resistor and an inductor, and we are energizing that circuit by a voltage source where this is the polarity. Now even if we change the polarity of this voltage source, the amount of current that will flow through this circuit, that will be same. There will be no change in that amplitude of that current that flows. So the circuits where we have resistor, inductor and capacitor, this type of passive elements, those circuits will be bilateral circuit or network. But if the network to be a bilateral, all the elements have to be bilateral in nature. As for example, transmission line is a good example of bilateral network. Now the next classification is active and passive network. An active element is an electrical component that either supplies electrical energy or power to that electrical network, or it can amplify or enhance the energy level of the signal that passes through it. As for examples, we can take vacuum tubes, batteries, generators, and also some semiconductor devices like transistor and op-amp. They are the examples of active elements. An electrical network that has at least one active element, that network is called active network. This is the symbol of voltage source and this is the symbol of transistor. Now passive element is that type of element where the element does not generate any electrical energy or power, rather it consumes or absorbs that electrical power or energy from that network. Resistors, inductors and capacitors are good examples of passive elements. Now a network that has all the passive elements, that network is called passive network. In case of passive element, in case of resistor, as we know that resistor absorbs, dissipates power in the form of heat, and also in case of inductor, the energy, electrical energy, is stored in the form of magnetic field, and in case of capacitor, that electrical energy is stored in the form of electric field. A transistor is an example of active element because it amplifies or enhances the power of the signal that passes through that transistor. And transformer, on the other hand, in case of transformer, on both the sides, the primary side and secondary side of the transformer, the power remains same. So power is not absorbed in case of transformer. So transformer itself is a good example of passive element. Next type of classification is based on time variance. Now in case of time invariant element, the characteristics of that element does not vary with time. So with time the characteristics will remain same. So we can say it is not a function of time, so performance will not change. And the network, electrical network, that has all the time invariant elements, that network is referred as time invariant network. Now, on contrary, if a network has at least one time variant network element, then that network is referred as time variant network. Now, what is time variant element? In case of time variant element, the characteristics of or behavior of that element or the performance of that element that varies with time. So the response of that element to an input, it will be a function of time. Now a network, as I said, if it is a time variant network, then at least there will be one time variant element. Now for the same element like resistor, it over time it can give the same performance. It may not vary with time, but it may also sometimes happens that with time the performance of the same element may degrade, may change or may degrade, we can say. So this type of phenomena is called aging effect. So with age the performance of the element may degrade. So in that case, it will be a time variant element, and if it has in a network, then that network will be referred as a time variant network. So in case of time variance or invariance network, the aging effect plays an important role. Now there is another type of classification, and that is based on that we classify a network into two classes, which is lumped network and distributed network. Now in case of lumped network, the network is built with definitely lumped elements. Now we have to see that what is a lumped element. In case of lumped any element, or in case of lumped network, the physical quantities like voltage and current, they are not functions of space, they are only functions of time. So they are assumed or considered as if they are concentrated at singular points over space. So there will be no variation in the physical quantities over the length of the lumped elements. Now the governing equations, if we want to represent the dynamics of that network, then the governing equations will be ordinary differential equations. As for examples, again we can take resistors, inductors and capacitors. They when they are part of the lumped network, they will be physically separated. We know that transmission line is lengthy, but if the length of the transmission line is less than a specific value, then that transmission line can be considered as lumped network, and we can assume and consider that as if their resistances, inductance or capacitance, those values, they are physically separated, or they are concentrated at singular points in the space. The lumped element model is made of series combination of resistance and inductance, and parallel combination of conductance and capacitance. Now, in case of distributed network, then the network is built with definitely distributed elements. And response of the network, like voltage and current, they are the physical quantities which are also functions of space along with time. So this time the response, these physical quantities, they will vary with space. So these physical quantities are not concentrated like lumped network at singular points in the space, rather they are distributed in the space. Now these physical quantities, as I said, over the length they will vary, and the dynamics of a distributed network are represented by partial differential equations. Now the transmission line after a certain length will be taken as distributed network, and also the filters that we use in RF or microwave circuits, they are also a good example of distributed network. Now next we have a different types of networks, as we can see here, and that is based on how different components in that network are connected with each other. The first connection or first network is T network, where we can see that we have three resistances. So in here, to represent all these types of networks, only resistances have been used. We can also think of impedances. If it is AC circuit, then in place of resistance we can think of impedance as well. So here in this network we can see that these three resistances are connected such a way that it looks like a T, that alphabet. So it is a T network, and these two resistances, they are called series resistance, and this is unbalanced T network. And if we have on the other side of that network, if we have suppose here another resistance and here we have another resistance connected, then that type of T network will be called as balanced T network. Now in this T network, if the value of R1 and R2 are same, then that type of network will be called as symmetrical T network. Otherwise, if this R1 and R2 are different, then that will be referred as unsymmetrical T network. Now the second type of connection that we can see here, again we have three resistances, but they are connected in such a way that it looks like pi, that we know in mathematics. Now here it is again an unbalanced pi network, and if suppose on the other side if we have another resistor here, then that will form a balanced pi network. Now here again, if the value of R2 and R3 are different, then that pi network will be called as unsymmetrical pi network. If they are having the same value, then it will be a symmetrical pi network. Now here we have two resistors and they are connected such a way that it looks like L alphabet, so it is L network. Now the next type of network is lattice network, where we can see four resistors connected in some fashion. Now the arms where R1 and R4 are connected, these arms are called series arms, and in that network the arms in where R2 and R3 are connected, those two arms are called cross arms. Now the next type of network is bridge network, where in a simple unbalanced T network, if the series arms, they are bridged by an impedance, or here it is resistance, then it will form a bridge network. That type of network will be called bridge network, and this is unbalanced. Now if we have similar type of structure on the other side that we have in this network, then that will be referred as balanced bridge network. Now the next type of network is recurrent and non-recurrent network. First I will come to the non-recurrent part. Here we can see that here we have a balanced T network. So initially it was a unbalanced T network where we didn't have any resistances on the other side, but when we connect them, then that makes a balanced T network. And here this is an example of balanced pi network. So here it was unbalanced pi network, so when we connect a resistance in this arm, then it makes a balanced pi network. But whether it is balanced T or pi network, but we have only one structure in that network. So this is non-recurrent network. But if we come to the recurrent part, what is the difference that we can notice here? That we have two balanced T networks here, or you can say multiple balanced T networks or same type of network, they are connected with each other. So in case of recurrent network, the same type of network, be it balanced or unbalanced, they will be repeated, they will be connected with each other. That could be true, that may be more than two also. So similarly, if we come to the other side, we can see here a balanced pi network is connected with another balanced pi network, so it forms a recurrent network. So here the same type of network, the same type of pattern recurs more than once, and this recurrent network has another name, which is ladder. So this network is also sometimes referred as ladder network. That there is another classification which is based on how many ports are there in that network, and based on that we can classify into say into one port network, two port network, or multi-port network. Now port is a combination of two terminals. So we can say a port comprises two terminals. So if in a network we have two terminals only, then that network will be referred as one port network. Inside this box or inside this black box, we can imagine an electrical network, whatever it is, but that network has only two terminals, and with that terminal we will be connecting the electromotive force, the force that will energize the circuit. So this is the example of one port network. Now in case of two port network, we will have two ports. That means each port will have two terminals, so altogether it will be having four terminals. So this is the example of two port network, and inside this black box we can think of again an electrical network. In case of two port network, one side or one port can be connected with the input or input supply, and the other side of that network can be connected with the load, or that can be referred as output side of that network. Now there is another type of network which is multi-port network. So in that network there will be more than two ports. That means there will be more than four terminals. So if suppose we have more than two electromotive forces, or the multiple energizing elements, then we can connect them at multiple port. And at the same time, if we want, we can also measure the output from multiple ports. So this is based on how many ports are there in that network. So in this class, I have discussed about different types of network that we'll be using in our future classes. So it will be easier for us to refer when I will only mention the name of that network. So with this, I end today's class. Thank you.